Okay, 13.3 is our last section of the year. We're going to talk about radian measure. Another way to measure angles is in radians. So far, y'all have only put angles in degrees, but now we're going to learn another way to measure the angles. And again, that's in radians, and that's what we're going to be using mostly in pre-cal. So what's a radian? Well, a radian is the measure of a central angle of a circle that intercepts an arc equal in length to the radius of the circle. Basically, what that means is when we talk about the unit circle, if the unit circle has a radius of 1, then its circumference would be 2 pi, since circumference is 2 pi times radius. So therefore, a full circle would have a measure of 2 pi radians. So what that means also is that a semicircle would just be pi radians, which matches at the same place as 180 degrees. So what that tells us is on the unit circle, pi and 180 land at the same angle. It doesn't mean that they are equal to each other, but it means that they are equivalent to each other, meaning they represent the same thing. So when we use pi and 180, it's not that they're equal, but we can substitute them in and out one for another. So what that's going to do is it'll help us as we determine how we can convert from degrees to radians and radians to degrees. So let's look first at converting degrees to radians. What you're going to do is you're going to take your degree measure and you're going to multiply by pi over 180. Why can we do pi over 180? Because pi and 180 are the same thing. So if I put pi over 180, technically that fraction is just 1. And multiplying by 1 doesn't change anything, it just changes the way it looks. So if we wanted to convert 30 degrees to radians, we want to take 30 and multiply by pi over 180. And when we do that, we get 30 pi over 180, which reduces to simply pi over 6. To convert 135 degrees to radians, we do 135 times pi over 180, which gives us 135 pi over 180. And when we reduce that, that gives us 3 pi over 4. To convert radians to degrees, we're going to take our radian and this time multiply by 180 over pi. So to convert negative 5 pi over 6 to degrees, the negative really doesn't do anything other than tell you a direction, which means it's just going to carry through the problem, so your answer will still be negative. If we take negative 5 pi over 6 times 180 over pi, that would give us negative 5 times 180 over 6 because the pi's are going to cancel out. And when you evaluate that, you get negative 150 degrees. It's important at this point that you're making sure you put those degree symbols. Not that you shouldn't have been doing it all along, but especially now that we're in two different types of measurement, you need to make sure you distinguish between what is a degree and what is a radian. Converting 4 pi over 3 to degrees, again, we multiply by 180 over pi. The pi's would cancel, and when we evaluate, we get 240. Just a quick word about radians. Radians can be expressed in terms of pi, which is typically how we're going to do it, or you can multiply it out to a decimal, and we'll talk about that next year. So in your homework, you're going to answer these questions. This is your homework here. You're going to convert the first 5 to radians and convert the second 5 to degrees.